Good day, viewers, and welcome to my YouTube channel, Maths with Adevik and Victor Adewale Adeleke. Here, our major focus is to teach you mathematics from the onset even of the tertiary institution. If you are yet to subscribe to my YouTube channel, do it to subscribe, like, and share this video. It is very important so that whenever I post materials like this, you will always get notified. And those of you that are in institutions, in tertiary institutions, that are having any special or difficult course that you feel like you want to learn, and you are a fan of Maths with Adevik, you can drop it on the comment section, being it physics or mathematics, and I will do well to provide solutions to your questions. Thank you. Okay, now we are having calculus, and this is quotient truth, still under differentiation. Now I want to use calculus to solve this question. You can see I want to use the quotient truth, sorry, to solve this question. This is a question that can be used by the quotient truth. Now this question is a kind of question that can also be used. We can also use the chain rule. That's the product rule. That's the reason why I wrote the product rule. This is the rule I'm going to talk about because I've already made a special class on this. But you know, as we always do it, I always try to tell you that all these rules are relative to each other. They are related to each other. So there's no separate rule in calculus. They are all saying the same thing, but they all have different advantages and disadvantages. So let's see how the product rule is going to provide solution to this particular question. Let's see what we can do to bring out the answer of this question. Okay, now this is for chain rule, sorry, for quotient rule. This will be represented. I'm going to use the product rule first, the quotient rule, sorry, first, before I use this other rule. So this is the U and this is the V. So for quotient rule, we can just say that the U dx would be equals to, you have your 2x. Why 2x? Because you can see if you find the derivative of this function, x squared plus 2 is a constant, so it terminates to 0. I've already explained that in my previous classes. It's a playlist. In case you are just stumbling into this video for the very first time, you can quickly check on my videos on the playlist calculus, and you will get to understand everything I'm doing here. So this x to the power of 2 plus 2, you see the 2 to the power of 2. So this 2 is a constant, it terminates to 0. Then we have x to the power of 2, which is inverted, and subtracting 1 from the 2, you have 1 left for the power of x. So we have 2x here. So also the same applies with v. So the v dx is what is going to be 3x squared, following that same procedure. Check on my video tagged techniques in differentiation. You understand what I'm doing here. So now we're going to plug all these values into this these parameters, or into this formula, the quotient formula. So this is dy dx. So this is the quotient rule I'm using now. So divide the dy dx will be equals to v. What is v? We know that v is what? Is x to the power of 3 times du dx, which is 2x, minus what? U. What is u? We have u to be x squared plus 2, producing what? Dv dx, which we found to be 3x squared, all divided by v squared. So we have x to the power of 3. Then don't forget this is square, but the square affect the 3, becomes 6. So we can just rewrite this as x to the power of 6. Okay, now once you've done that, now the next thing you have to do here is, okay, we can just clean this line. This is algebra. Clean this line and say x to the power of 6 here, and also x to the power of 6 here. Yeah, we are still very correct. So what happens here? So we have x to the power of 4 here. X to the power of 4 here. So what happens? 4 minus 6, the rule of indices. So dy dx will be equals to 4 minus 6, because you have both x. So we have x to the power of minus 2. Then you have your 2. So we have 2x minus 2. Then minus, what happens here? It also affects the same thing. So we have 3x minus 4, x squared plus 2. And that is your final solution to the question. This is your final solution to the question using the what? Using the quotient rule. So the quotient rule applies. Now what about the product rule? Let's assume we are using the product rule. Mind you, for the product rule, du dx, for the product rule, if you want to use the product rule, you cannot allow it look like this, because the only formula, the differentiation formula that can provide solution to problems like this that are fractions is only the quotient rule. The quotient rule is the only rule that can provide solution to fractional problems in calculus, except you want to make it look like this. You can see I manipulated the x to the power of 3, which now looks like what, x to the negative 3. This is still, this is what looks like. This now looks like a product, because you can see the product of these two will give you the same thing as this to the power of negative 3. So we've manipulated, mathematically manipulated this to look like what we want. So from ends now we can now provide solution following the system of what, of mathematics. So the system of differentiation. So what do we do now? We find du dx. Du dx remains 2x, but you can see that dv dx changed. We now have minus 3x to the power of minus 4. Why minus 4? Minus 4 because you subtracted 1 from negative 3, so it becomes negative 4. So once you've gotten that, the next thing to do is to plug into the product formula, which is dy dx is equals to v. What is the v? The x to the power of negative 3 du ds, which is 2x, 2, okay, times 2x. Then what we have plus, what is u? U is what? X squared plus 2 producing with what? Negative 3. Now producing with dv dx. And dv dx is what? Is negative 3. So the negative is going to affect the positive, because positive times negative is negative. So we have just 3x to the power of negative 4. So from here you can see that minus 3, this is 1. So by the law of indices, x to the power of negative 3 times x to the power of 1 becomes x to the power of what? Of negative 2. So what do we have? So we have 2x minus 2, then minus 3x minus 4. Okay, this is 4. Let me write properly. 4, and we have x what? X squared plus 2. This is also, you can see the answer looks very much alike as the what, as the answer we got when we used the quotient rule. So any of these rules are applicable, but mind you, there are some questions that are very technical and you just want to use the quotient rule. That's the reason I always told you from the very beginning of the class. If you have been following me on the playlist, I told you, I said that what terminates the existence of a regime or a formula is when another powerful or a potent regime comes that surpasses or provides more accurate solutions, or faster, sorry, not accurate, faster solutions to problems than the other. That is just what mathematics is still all about. If you're yet to subscribe to my YouTube channel, do well to subscribe, like and share. It is very important so that whenever I post helpful materials like this, you always get notified. Stay tuned.